Gude! Today's video will not be a technical walkthrough again. Most of you probably will know that I have passion for open voice technology or text-to-speech currently. And new implementations for good sounding text-to-speech is primarily based on a relatively new technology called AI or artificial intelligence, or said in my German mother tongue, KI, künstliche Intelligenz. So I thought, maybe I should learn something about that AI thing, because it is an important part of the text-to-speech journey I am in. So I read some articles, watched YouTube videos on AI or machine learning stuff, and wow, I found lots of videos and stuff like that with input layer neural networks, hidden layers, output layers, neurons flying from forward to backward and reverse, and cheating and watching the solution at the output layer, going back with some lessons learned stuff, whatever. It's a really, it seems like a big neuron party going on. So, but honestly, I must say right now, I am not smart enough to understand that. I'm working on it, but I'm not really smart enough to find all that crazy stuff to understand that. So that's probably one of the most important things I would like to do in that video. A great shout out to all the people out there who understand that amazing field on machine learning and writing documents, articles, papers on that, or people developing software solutions based on that papers. So really, honestly, you are amazing. I mean that really, really honest. You are really amazing. So that said, I try to find out what this AI, artificial intelligence, is all about. So I stepped a little step back, and not in the technical detail, I try to find a way for me to understand that field. But honestly, I have to say I do not like that AI or KI buzzword, because it sounds, to me at least, it's sounding like an empty phrase, an empty buzzword printed in capital letters on the front page of a manager magazine. Your company needs AI. Why? Because. Okay. So I do not like the word, but I am fascinated by the technology that is driving that buzzword. And when I get it right, that is machine learning. So I thought, let's take it from there. Let's take a look, what is machine learning? And as I'm just a normal guy, I have no experience on machine learning or neural networks or a great understanding of math. So I really struggle and try to find a simple understanding of a, at least for me, complex looking topic. So I thought, machine learning. Just two simple words, machine and learning. And honestly, for me, these two words, they do not match. They do not fit. I know machines and I know learning, but together that doesn't make any sense. Because machines, they do not learn. People learn. Animals learn. Probably every life form is able to learn. But machines, not. So I thought, as being a software developer myself, I have learned how to implement or to translate a written use case to machine understandable code, to clear instructions that can be executed by the machine. So, in my opinion, machines are just for executing clear instructions, and they are, for that reason, they are dumb. Not you, laptop, you are great. I mean, just the other technology around you. So, you are great. But, so, what does it mean, machine learning? So, I stepped another way, or stepped back, and ignored that machine stuff. And I thought, what do I know? The simple answer is, I know this guy. I know me. So how do I personally learn? Or to make it more common or general, let's take a part in life everybody of us has gone through. And that's the part where we all were newly born childs. So, and to be honest, the feature list when we were born, so our factory defaults is really limited, the functionality. So we were able to breathe, to drink, and to poop. So that's all. Okay, sorry, evolution. I know human body is amazing, great, but you get the idea. So let's take, for example, the ability to recognize a cat being a cat or a dog being a dog. That is not given out of the box. Out of the box is a little bit sounding weird when it comes to a newly born baby, huh? Okay, but this is nothing we can, being humans by default. We have to learn what is a cat. We have to learn what is a dog. So I thought, let's take the technical part completely away. And I have a short disclaimer because I think that video will probably be the worst and less researched video talk on machine learning or stuff like that, because I am no expert, no experienced user. I just tried to find a way to understand that technology, that complex scenario. So please do not take that video too serious, or write in the comments where I made or tell you probably really big mistakes. But I would like to share my simple-minded thoughts, how I understand or think to understand machine learning. So that as a short disclaimer. So let's take a simple example. When a new child is born, what do parents probably do? They take their child, put it into a stroller, and go outside and show their baby the surrounding, their area. And let's take a cat. So a cat is crossing the street. What probably most parents will do? They will point to that animal, to that pattern in crazy data. So they will point to that cat and they will say cat or meow. They will probably not say lovely child. Within the field you can see right now there is an animal where the human species set its name to cat some decades ago. So now probably not. So you will make a direct connection, direct link, cat. And what I could imagine what will happen in the brain, and again, probably this is horribly wrong. It's just the way I could imagine it and it helped me understanding some things. So the brain will probably look, do I have a model or a folder or whatever you will call it, called or labeled with cat? No? Okay, so let's create a new empty model. Let's name it cat, and we need attributes. Let's say 4 feet. 4 feet is an attribute for model cat. Okay, everything's great. The parents and the kid in the stroller, they are moving forward and they are crossing the next street and a cat is on the street. Before parents, or maybe we call them ground truth, can say anything, the brain probably will make some, let's say, reverse lookup. I see a pattern with 4 feet. Do I have a model matching that 4 feet attribute? It's a cat. So the brain will probably make a prediction and say, let's say I'm 60% sure that is a cat. And then the parents will say, cat. And probably the kid's brain will make a little neuron party. They, whoa, we were right. That's a cat. I knew it. It's a cat. So, and the model will get or will be raised up. So because it has been approved by the parents, so by the ground truth. So, long story short, moving forward, next corner, a dog is crossing the street. Or to be more precise, a healthy dog with 4 feet is crossing the street. And the brain will do the same thing. 4 feet, part of the model cat. Model has been approved previously. I'm 70% safe that's a cat. Now our ground truth, parents, will say, dog. Really? Okay, model is wrong. I have no model or folder or whatever with the label dog. So a new model is created with additional attributes. And every cat, every dog the child will see will make the model better and better and better. And at some point in time, the model will be so good that it has no problem identifying a false positive. So let's think the child is growing up and it's 10 years old and it's going on a walk with its parents and there is a dog crossing the street. And the parents say, oh, elephant. Probably the brain will not adjust the model, which has been trained for 10 years. Probably the child will look to the parents and ask, are you drunk? So what I try to tell you is that after several steps of training with lots of training data, your model is good enough to identify false positives. So, and that is probably a simple and horribly wrong imagination of how learning is working. So, but that's the way I hope I can understand it. So, but let's translate that way I think humans or animals in general will learn to the machine. I still try to understand that machine learning, or why is it needed? What is wrong with the classical if, then, else programming? So probably there's nothing wrong with that way of programming, but some use cases require that machine learning. And that is probably the case when it comes to recognize patterns in lots of chaotic data. Where is that helpful? For sure, let's take the cat and dog example. You cannot program in a classical way to identify a cat. How would that work? If the pixel in that picture in coordinate x10 and y20 is RGB value gray, then cat equals true. Well, no way. Or let's take the example of cars, self-driving cars. I personally would prefer sitting in a self-driving car which is able to identify a red light at the traffic light. I would feel safer, way more safe than a car saying red traffic light. Never heard of that. So, but in that problem, you cannot code in the classical way. So how does it work? As being more into text-to-speech, I have no experience on image recognition, and so I'm not sure if that is the case, but I think we can translate the way newborn babies or humans or animals in general learn to a machine learning process. So we need training data. We need pictures, tens, hundreds, thousands of pictures. Let's stick with the cat example. I want to train a model which is able to identify a cat or parts of a cat, whatever, when it's at the border of a picture. I would like to identify cats. So I have a folder with 10,000 of JPEG image files, labeled from image 1 to image 10,000. And all types of pictures. Small pictures, big pictures, colored pictures, grayscale pictures, shaded pictures where the camera was moving while taking the photo. All the pictures with cats, with one cat, with several cats, without any cat, with a cat being cut off at the end at the picture. So, and that's the data I need. The same as probably a human child would need several cats to get a good model. Okay, the brain, the evolution of the brain, not just the human brain, but brains in general, we have lots of evolutionary progress. So the human brain will need less training data than a computer program. But if I have my folder with image 1 JPEG to image 10,000 JPEG with lots of variation with cats or no cats, but what does a computer program not have that everybody of us have, or at least had? Parents. So the simple version is we need to mock, to replace our parents, which is called the ground truth. So how do we do that? Let's create a CSV file. A simple CSV file, 2 columns, left column, just the file name. Image 1 JPEG, image 10,000 JPEG. The second column is saying cat, yes or no. So a human, or humans probably, have to check every photo of these 10,000 pictures and write a yes or a no in that CSV file if there is a one or several cats in the picture or not. And then, let's say, for example, you write a program with that all crazy machine learning stuff. I have no experienced user with. So you write a program which will simply take a batch size, let's say 32 images. So it will look in that CSV file and say, randomly give me 32 image files with cat equals yes. So, and now the system will try to find commons. What have all these images in common that my ground truth, my parents told me there is a cat. So, and the machine can just analyze pictures as a machine can analyze pictures. Are they all the same file size? Probably not. Are they all have the same resolution? Probably not either. Are they having whatever? So, but let's say all the pictures of these 32 cats have taken outside on a sunny day. The sun is good visible. So all of these pictures have a high part of yellow color, which is reasoned by the visible sun. So the model could learn, I know what a cat means. If, for a random example, the yellow part of the picture is higher than 12%. So then it will randomly grab one picture and make some validation. So let's check if the model is good. So it will take a random picture and it will not cheat. It will not look in the cat yes no column. So, and then we'll analyze that picture and say, okay, luckily that randomly picked picture has a cat and it's taken outside where the sun is good to see. So the model will check, yellow higher than 12%. Great. My prediction is there is a cat. And prediction is right, but for the wrong reasons, obviously, because the sun in the picture is not an argument to have a cat in it. So, taking the next picture in the validation part, that has a cat and it's intended recorded or taken within the house. So, no sun is shining or no sun is visible, and the model will fail. And that is probably the simple way the model is learning. And that is really, I do not understand, but I understood that there is an input layer where the information is put in, then it's going through several hidden layers, and at the output layer, it will be validated and checked if the prediction is right. And then it will run backwards to the input layer and adjust all that neurons activate, deactivate, whatever in the middle, and forward, backward, and so on. And that's for lots of repeats and steps and so on. So that is, and again, that is just my little thoughts, where I thought this might be a simple, an explanation of a, for me at least, complex topic like machine learning. Understandable for a simple mind like mine. And hopefully I will get deeper in that, or more accurate. So please let me know in the comments if you, on the one side, find that simple-minded explanation or analogy to little baby children or animals in general, if you find that helpful. Or please, and that's really, I hope, if that's really completely wrong, what I think or what I told you, then please let me know in the comments and say, you are really crazy. So that's it. I hope you find it helpful, or please correct me in the comments. I hope to get better on that special topic. I'm interested, and I know I have a lot of way to go to be experienced in that. So that's it. I wish you a nice rest of the day, and we will see us and hear us in future. Bye!